For a new entry, we're going to be graphing y equals ax squared plus bx plus c. So whereas before we just had ax squared and sometimes ax squared plus c, we're throwing in this other term with just x and no exponent. And this is the standard form of a quadratic equation, which you saw in the previous entry. If we flip back to the previous entry, you can see that the parent function y equals x squared forms a parabola, right, a U shape. And to change that parabola, what we did is we multiplied x squared by a number. And if you recall from the video, that made this go up faster or up slower. So it got wider or it got narrower. We also added a number at the end, so like 1/2 x squared plus 1. The 1/2 makes this wider, right? It's wider, and the plus 1 makes it go start at 1. If it was -5, it would start at -5. So in all these instances, we've been working just on this y-axis. We haven't shifted it over here, or down here, or, up here. But in fact, a lot of quadratic equations don't start in the middle, okay, or start somewhere on this line. Oftentimes they're somewhere around here, or even upside down around here. You see that a lot in real-world scenarios where both of the values you're using for x and for y are positive, and you're tracking something that goes up and then goes down, so like a falling object. So now we're going to talk about what happens when we have a value for b and how to graph that situation. So in your standard form of a quadratic equation, y equals ax squared plus bx plus c. It's tough to see, but I did a in blue, b in red, and c is in purple. So in this standard form, the value of b, so the number in the middle here, affects the position of the axis of symmetry. And if you recall what the axis of symmetry is it's that imaginary line that goes through the center of your parabola. And on the axis of symmetry is the minimum or the maximum vertex. So right here. In the case of this one, the vertex was right here. So in all these cases, the axis of symmetry, again, was the y-axis. It was right in the middle. Now when we throw b into the mix, okay, it affects where that axis of symmetry goes. We're going to do an example to show you how that works. So we have a formula for the axis of symmetry for any quadratic equation. And that formula is, to find the axis of symmetry, it would be x equals negative b over 2a. And you get b and a from the numbers that are the values that are in your quadratic equation. So if this was a 3, here would be negative 3. If a was a 2, it'd be negative 3 over 2 times 2, which would then be negative 3/4. So then you have an axis of symmetry at x equals negative 3/4. And we're going to see that because our next example, we're going to be graphing a quadratic equation in standard form. Graph the equation y equals x squared minus 6x plus 4. And our first step is going to be to find the axis of symmetry. So the formula again is x equals negative b over 2a. And my value for b is negative 6. And my value for a is 1. So my formula is going to be x equals negative 6 over 2 times 1. And this would give me 6 over 2, which is then 3. So my axis of symmetry is x equals 3. That means that along the line x equals 3 should split my parabola in half. And I can show that just putting a solid dashed line right through it. My second step is to find the vertex. So I know the vertex lies on this point, or sorry, on this line, the axis of symmetry. And I know the value is when x is 3. So to find the vertex, I'm going to put 3 into my function, or my quadratic equation. So y equals 3 squared minus 6 times 3, and then plus 4. So I'm getting this equation, right, y equals x squared minus 6x plus 4, right from here. And then I do that math out, I get 9 minus 18 is negative 9, plus 4 should give me negative 5. So my vertex is going to be at 3, negative 5. So I know that that is the point that's on the line. Third step is to find the y-intercept, which is actually really easy because it's always going to be the value of c. Because when x is 0, these two values cancel each other out. So the y-intercept is going to be this number right here, which is just like slope-intercept form, y equals mx plus b. It's always that number that's by itself. So I know that my function crosses at 4. So it's right here. I also know that because it's symmetrical along this line, that if this is 3 away from my axis of symmetry to the left, it's also 3 away to the right. So now I have 3 points. My last step before I actually graph the line is to find one more point. So we're going to find, use the equation y equals x squared minus 6x plus 4, and just find any other point, because we want to see how this function curves, and right now we could really just make a V when I know it's supposed to be a U shape. So when you find your next point, you should try and make it so that it's either around here, okay, or around here. So use like 1 for your x value. That's what I'm going to do. So if I insert 1 for x, I have 1 squared, which is 1, minus 6 times 1. So 1 minus 6 is negative 5. And then plus 4, and that gives me a y value of negative 1. So I plot the point 1, negative 1, which is right here. And I know that they're symmetrical, so if this is 2 away, then it's also 2 away over here. And all of a sudden I've got a U shape that formed pretty well. So that's my parabola. So this would be the graph of the equation y equals x squared minus 6x plus 4. Now, when in doubt, you can always make a table of values, like we did here, and then plot the points and list the table of values. But once we start getting into word problems, the axis of symmetry, and the vertex, and the maximum and the minimum, it's actually all going to mean something based on the word problem. So you really want to get used to finding these points, okay, in this line of axis of symmetry.